Hello, welcome to Science with Mrs. Blackburn. Today we're going to do something a little bit different. We are going to be doing some drawing. This is something that we've done in class, and I wanted to post this video so you could review and redraw these different tectonic plate images, or just so you can watch this just to review for quizzes and tests. So let's get started. Before we do anything else, I want to show you some images that we see here on the screen. Okay, this is just a review of what the layers of the Earth are. And we drew this in class, but I just want to go over this really quickly so the video won't be too long. So we know that the Earth is made of layers, like we said earlier, kind of like ogres and onions. The Earth has layers. And so the top layer, the very outer layer, is going to be the crust right there. And the crust is going to be very dense and very, very thin. If the Earth were an apple, then the crust would be the skin of the apple. That's how tiny it is compared to the other layers. The next layer down is going to be the mantle, and it's divided into the upper and lower mantle. And then it's going to get hotter as you go deeper within the Earth. That's one thing that's really important. Heat and pressure both increase the deeper you go down into the Earth's layers. The next layer down is going to be the outer core. Now this is going to be liquid. It's going to be so hot that all of this rock is going to be totally molten or melted by the time we get to the outer core, so it will be liquid. The outer core is made of iron, and so as the Earth rotates, the actual outer core, because it's liquid, is also going to move around, and that's what generates our magnetic field. And then finally, on the inside, we have the inner core, which is going to be totally solid, even though it's way hotter than the outer core. That's counterintuitive, which means it's not what you think it would be, because we would expect that inner core to be totally solid because it's so much hotter than all the other layers. However, there's so much pressure on that inner core that it's not going to be able to get out of the solid state of matter. Okay, so everything that we talk about from here on out is mostly going to deal with the crust and that upper mantle, because those together make something called the lithosphere. Okay, the lithosphere is going to be the crust and the upper mantle, which will be comprised of tectonic plates. So this diagram kind of leads us to think that everything on the Earth is going to be solid, like that crust is going to be one big giant solid piece, but it's not. As we learn today, we are going to see how dynamic the Earth really is. So instead of thinking about that crust as one big solid piece, you can actually think about it as a jigsaw puzzle, okay? With all different pieces that are sliding together, that are fitting together and joining together. And these jigsaw pieces can do some weird things, which is what we're going to start talking about today. We're going to talk about plate tectonics. We call each of these little pieces of crust, along with the upper mantle, tectonic plates. They move. We'll talk about how here in a moment. And the movement of these plates and the behavior of these plates is going to give us some really cool geographic features on the surface of the Earth. Now, this is what the plates actually are like. That's the puzzle that if we were to lay the Earth out flat like a puzzle, then this is what we would get. You have different plates, the North American plate, Caribbean plate, South American plate, all of these, and that's how we how these plates are comprised. Now here's the thing. Along those edges where you see the plates over here, along the joints between those plates, you're going to have some really cool things happen. And so we're going to talk about ways those plates can move and what they can do. So I'm going to go back to my piece of paper over here, and we're going to do some drawings. So before we get started, I'm going to show you my hands, and we did this in class. If I were to put my hands together like so, okay, let's pretend that each hand is a different tectonic plate, and if I put them together, you see between my index fingers, those would be the tectonic plate boundaries, the boundaries between them. So let's think of some ways that I could move my hands. So these boundaries can be where the plate, they can either be just sitting right next to each other, they can move apart, they can kind of move too close together and kind of bunch up on each other, or they could slide past each other. Those are our options. So those options give us the three different categories of plate boundaries. The first one that we're going to talk about is called the divergent plate boundaries, where the plates move apart. Okay, so we have divergent plate boundaries where they move apart, you have convergent where they come together, and you have transform boundaries where they're going to kind of shift back and forth between each other. And so the first one will be divergent. The word diverge means to move apart, so that's why we're going to talk about that. So there are two different types of divergent plate boundaries, and the first one we're going to talk about is oceanic. So in class we talked about oceanic crust, and the oceanic crust, of course, is going to be our seafloors, and it's going to be thinner, and it's going to be a lot more dense than continental crust. So this type of plate boundary is going to happen on oceanic crust. So what we're going to see, let's go ahead and let's draw a little ocean line here. This is, of course, going to happen underwater, and we are going to have two pieces of oceanic crust that we're going to draw here, and again, it's going to be kind of thin. Okay, and so what we're looking at here are oceanic crust plates. That's what we're looking at here. What's going to happen is under these, sorry about that, that's the announcement. Under the oceanic crust, you're going to have what? You're going to have the mantle, and it's going to be made of magma or molten rock. So what's going to happen with that mantle is, remember that under there, under the mantle, you're going to have that outer core, and it's going to be super hot. So the part of the mantle that's touching the outer core is going to also get very hot. What happens to hot fluids, liquids or gases? They're going to rise. And remember that this mantle is semi-solid, okay? So it's going to be kind of jelly-like liquidy, so it's going to do this. Not total liquid though, that's the outer core. But this is going to be semi-solid, so this magma is going to warm up when it's down here, and as it warms up, it's going to rise because it will be less dense than the other magma. When it touches the crust, however, it will start sinking again because it's going to cool down when it gets up to the crust. Okay, so it's going to heat up down here, rise because it's been heated up, and it will be less dense. Once it touches that oceanic crust, it's going to cool down and lower back down again and repeat the process. This is a super important process that happens. We call this a convection current. So important, a convection current. That is when a fluid, again a fluid is a liquid or a gas, is going to heat up, and as it heats up, it will rise. Something's going to be up at the top to cool it down, and it will sink again, get heated up back at the bottom, rise again, cool again. This happens in air masses in our atmosphere. It happens in bodies of water. And so you're going to see this again when you talk about other phenomena that happens on Earth. So this is a convection current. Convection currents in the mantle are going to be what drive plate tectonics. These plates don't just magically move all by themselves. It's this process of convection under the Earth's surface that is going to cause it. So in this first type of plate boundary that we're going to talk about, we're talking about two convection currents that are moving opposite from one another. And as that mantle moves, it's going to start pulling at this really thin oceanic crust. Well, what's going to happen when that occurs? What's going to happen is some of this magma is going to start melting that crust where it's being torn apart kind of thin, and it's going to create a fissure. That's just like a little opening that this mantle can start coming through. But it's not going to stay open for a really long time. What's going to happen is you're going to have lava. And as that lava cools, it will make new rock. Okay, it's going to cool and make new rock, but again, we have this happening over and over and over again. This is a convection current, it's a cycle. So this little fissure is going to keep being torn and filling back up with lava. It's going to be hardening and then pulling back apart. Okay, and so as this occurs, you're going to have new rock at the sides of the fissure. And then as we go farther out this way with the oceanic crust, it's going to be pulled that opposite ways. As you go farther out, what's going to happen is your crust is going to end up being older rock as you go farther out. Okay, and this process is going to create some really neat things. One really cool example of this is the Mid-Atlantic Ridge. And a ridge is going to be a high area compared to the other areas around it. And so this is going to be basically like a mountain chain type deal that's occurring in the Atlantic Ocean, and that it was created by this. This phenomena has its own name, and it is called seafloor spreading. And all of this is happening in the bottom of the ocean in that oceanic crust. So that is one of the ways that divergent plate boundaries can occur. So now that we understand this, let's talk about a different type of plate boundary. This is going to be a divergent plate boundary, but it's going to be continental. So now that we know oceanic, let's talk about continental. So the second type of divergent plate boundary we want to know about is what happens if the same phenomenon happens, but instead of it happening underneath oceanic crust, what if it happens under continental crust? I think this is really fascinating. So this will be a continental divergent plate boundary. So at this point, we're talking about continental crust. So it's not under the ocean, okay? We're talking about land. So I'm gonna just draw some what will look like meaningless shapes, but you're gonna see what I'm doing here in a second. So first of all, I'm gonna draw just kind of a hill right here, okay? And then I'm going to draw some of this continental crust. So remember, this continental crust is going to be thicker than the oceanic crust. So this in orange is the continental crust that I'm drawing, okay? So this is the separation between the continental crust and the mantle. And then under here is going to be the mantle. Now again, a convection current is going to be happening in this mantle at all times because all that magma is going to be heated up by the outer core, and as it rises up because it's less dense, it's going to sink again once it touches that crust. So let's draw that here. Now remember, in the last picture we had an example of two convection currents, 1, 2, happening at the same time but going in opposite directions. And we're going to draw the same thing here. So just a reminder, as this magma is heated, it's going to heat up and it's going to rise. It's going to heat up and rise. And then when it gets up here, it's going to cool down. and sink. And this will happen over and over and over again. All right? This will cause movement. Now, this time we have the same phenomenon pulling at the crust. But remember, the continental crust is going to be way thicker, way less dense than the oceanic crust. So you're not going to get a clean break like you did with the oceanic divergent plate boundary. It's going to create what's known as a rift. It's going to be jagged. So I'm going to draw and show how that's going to be jagged on that continental crust. Okay, like that. It's not going to be a total clean break. It's going to kind of be jaggedy and ugly, I guess is how we could say it. So not a clean break. Okay, and this creates what we call a rift valley. There's one, and it's called the East Africa Rift Valley is one that's really big and really famous. And what's going to happen is you're going to have all this land, and it's going to slope downward. Underneath that crust is going to be two convection currents that are going to be pulling opposite ways. And the cool thing about this is sometimes it can rift so much that it goes below sea level, and as it rains and everything, you're going to actually end up with a little ocean basin in here. Okay, so a really, really neat geographic feature that can happen as a result of this phenomenon. So I'm going to end this video now, and what we're going to do is I will post another video that shows our convergent plate boundaries. So make sure you watch out for that second video. Thank you for watching.